Okay. Yeah, go ahead. Any question?
I'm sorry. I couldn't figure out the last four problems of the fill in the blank. It was talking about the range of age in the upper 25th percentile of passengers. And
Okay.
those type of, I didn't know how to do it on the mini tab, maybe.
Okay. So very simple. Let me explain to you. So I'm going on whiteboard so I can explain to you. Can you see my whiteboard?
Yes, sir.
So if you arrange the data, let's say this is, let me take another color. Okay. Let's say this is your minimum point, and let's say this is your range of, this is maximum. So this is minimum value in a data. This is maximum value. Okay. Now, if you divide this data into two parts, which is called median. So median, what is median? Median is a center point, or 50% is here. You have a data 50% here, 50% here. So now if I ask question, what is your upper part range? So whatever is medium, let's say X value. So what is the range? This is max minus X. So this is upper 50%. So whatever value will be, that will be upper 50%. If I ask lower 50%, X minus min, which is lower 50%. Now, okay, so this is a median, role of median. I'm going to answer one by one. Now let's go into the quartile. So yeah, I'm going to explain that also. So quartile, what is quartile? Quarter means if you divide your data into four parts, which is quartile. So let me take the first 50% here, 50 percentile, and I divide this into two parts. Okay. So this is 25%. This is next 25%. Similarly, if I do this part, I take only this part and I divide this data into again two parts. So this is 25%. Basically what I'm doing, I'm dividing the data into four equal parts, and this is 25%. So how I can, this is minimum, this is called Q1, quartile 1, this is called quartile 2 or median, this is called quartile 3. So there is a concept called interquartile range. Means what is the difference between, what is the interquartile range? Interquartile range, or IQR, you can clearly see in the equal to nothing but Q3 minus Q1. Okay, so this is Q3, this is Q1, whatever difference, that is called interquartile range. Now we have a question like you are asking, what is the upper 25% of the data? What is the upper? See, this is your data, this is upper 25%. So what you need to do, you need to take max value, you need to take Q3 value, and you get upper. What is the lower quartile? This is the lower quartile. Q1 minus minimum value. You get, what is the third quartile? This is a third. Do you get the answer of your question that you are asking? So in Minitab, so okay, you got it. So basically, this is based on the concept. Questions, if you have data, you just do the, you can get all these numbers. You can get minimum value, you can get maximum value, you can get this number, you can get this number. So I'm just going to show you in Minitab. And Jamie, I'm going to explain how to get your Minitab. So let me open the file and let me desktop. Here we go, Titanic data. So this is the data basically you are dealing with. Okay. Now where you can do these things, basically, you know, this is the variable where you can operate all the things. So I'm going here, statistics, basic statistics. Oh, sorry, you can't see Minitab. Just a minute, sorry. Just a minute, let me see, I forgot to do that. Can you see my Minitab? Okay, so
Yes.
basically this is the data you are dealing with in this week assignment. And okay, this is basically a real data that is about Titanic, that you know about the Titanic story. Probably most of you have also watched that movie Titanic. So this is the real data about the Titanic passenger. You know, they collected the sample. That time we did not have automated data collection method. So whatever researcher found, this is about 2,478 or, you know, odd data, odd customer or passenger data on Titanic. Now look into that. So basically we are dealing with age variable, and like you ask about range, different quartile range. So I go under statistics, basic statistics, display basic statistics. Now you can clearly see the basic statistics, descriptive statistics can only be applied on the number values. So here only you can see the variables which are number. Our male is, you know, 0, 1. So you can say age, again, ratio. However, male is only, you know, nominal. 2 categories. Here in pound is also ratio. So you can see, you first always check which variable is relevant to what question. So, okay, now I selected age variable. Now I see under statistics, as you are asking, we have, let me remove all, none. Okay, so how we were doing the quartiles. So here you can see we need median so that we can see the middle point. We need lowest value. What is the minimum value? So here, can you see the minimum? Here we have a maximum value and we have a minimum value. So if we get these 3 numbers, we can get, now we need quartiles. Third quartiles, interquartile range, we need first quartile. Median is second quartile, third quartile. So we got all the numbers, and now just play with this and you have all the numbers to do. At the minimum value, the maximum value, Q1, median, Q3. So Kelly, you can answer all the questions because so what is 1482073? I don't get your question. What is 1482073? Okay. So this is about this. Do you have any other question? Jamie, what is your question? I'm having trouble figuring out how to use Minitab in general. Do you have any suggestion or videos to watch on? Okay, here we go. And This is and here you can see I have lots of videos related to all about Minitab. I did for each module, and you can see most of the videos are related to Minitab, except few. So, I mean, you feel free to watch and let me know if you don't understand, Jamie, any particular concept. I can make more videos.
Okay, thank you. do you have a link to those? Like, all I'm seeing is a Minitab screen. If you can just post it in the chat. Thank you so much.
So Jamie, also just look into this. And can you see here? This is, let's say, okay, here we go. Module 2, this is module 2 that you are dealing with. Here you can see module link. And here you can see the previous recording right at the bottom of each module. Look into this, already posted. So you can see all the, can you see these things? So already there, you get your time to, oh, just a minute, let me also just news, can you see the Canvas page?
Yes.
Okay, right here, can you see now? This is at the end of the module. Module 2 links. I shared all the videos right here. And also you can see at the end of the module, where am I? Okay, previous course recorded session link. Jamie, is it? This is what you.
I'll watch over those. I've never used Minitab, and I, for some reason, can't even get it to download onto my computer. I'm having to use like the cloud version, and I don't understand where I'm supposed to put certain things, and so I'm just trying to figure it out. Is all. I'm really confused.
No worry. Are you using Windows or are you using Mac?
Windows.
Okay, so just go here. Just I shared the link in announcement. Here So first install. Okay, go ahead. I mean, I did the exactly same thing. First, you download on desktop. This download and use 30 days trial. Once you do that, then you can, once you do start 30-day free trial, then you will be asked to use your Eastern email or whatever. And then it will pop up the Eastern login and password page. And once you do, then you will have exact, like, I'm using on my computer. So you will have this on your computer.
Okay.
It will.
I'll try again, because when I was trying to click the link to download it, it said web page not available or link not available. So it wasn't letting me actually like continue on. So maybe I'll try it again today and see if I can get it to work.
Please use this link, I think, because this which is shared in announcement, under announcement, please use this link only, and you will be successful.
Okay, I will give it a try. Thank you for your help.
And let me know in case if you have any issue. And what I was trying to say, so always, do this and use your EW credentials and you will have no problem. But, once in a week, it will ask again and again. So no problem. But, cloud version is also available for Mac user.
Yeah, can we use the cloud version of Minitab, that link on the top, the first line, we recommend you? Is that okay?
So here we go under, cloud version. And here you go. Okay. And now I have to put my email. Sorry. Okay, next. And then Eastern. So Okay, probably it will ask my, okay, I think it is going directly already. So yeah, this is cloud version. So here you can open the cloud version, worksheet, Minitab, new, download a copy. So what, same thing I'm just going to demonstrate here. So can you see my, yeah, let me open the data, then I will show you. Okay, that is what I'm going to show you. So let me share my screen, whole screen, so that you can see. Can you see the data that I have in here, or let me open in Excel that. Okay, right here, I have Titanic data, which is opening in Minitab already. So let me open with Excel. Okay, so a very simple way. I'm just copying all the data right here. So this is simplest I did. But here there is a one chance that in case if you miss or if you forget to select any row or column, and here we go. Okay, can you see, Preeti? So here I have, okay, here it is still loading. Make sure that every data, every single entry is properly copied and pasted here.
Oh, so we're supposed to copy from Excel download to Minitab. Okay.
So this is easiest. I mean, I normally, but I never use the cloud version. There's a data here you can see, and you can copy. So here you have, file you can open, and you can from project or from, you have to or local file here. So this is another one. So I just do the local file and let's say download, whereas let's say this is the data I have. So you can download from local. Oh, I think I did something.
Got it. Thank you.
So, I mean, you can simply play with this. So here I have this data, and now what I did with the Titanic data, similarly, you can do with basic statistics, display basic statistics, select the GRE data, for example. Under statistics, you can choose the, whatever analysis you need, you can just choose, and you can just get the result right here. Here you can see all the results. Is it making sense?
Yeah, thank you.
You're welcome. Any other question anyone is having, please ask me, because I'm here to explain your doubts, questions. The rest of the things are already recorded. I already explained the concepts, every concept, their application. When you go through those video, if you have time, just go through and you will get all the concept explained, every single calculation using Minitab.
Could you explain? I went over to, I was listening to your video on for the chapter for stem and leaf display. And I didn't quite understand that part, you know, where you count, I think it's chapter 3.1, page
STEM.
59, stem and leaf. Yeah,
So
I didn't get that one.
Under graphs, you go under graph, and here you have, let's say, and here you get the analysis. Actually, this stem and leaf we usually do when we, I mean, class 6th or 7th standard. So this is what, you know, 0 under 0, you know, so let me start so 0, and, you know, after 0, these are the numbers, means on the top. So 4, this is a stem, this is leaf. So basically, whatever these numbers, you know, here you can say up to this, they are under, you know, less than 1 year. These are 1, 1, 1, 1, 1. Here 5, 5, and you can see. So under 1 means 10, 11, 12 up to 19. 2 means 20 to 29. 3 means 30 to 39. 4 means 40 to 49, and so on and so forth. So basically, this is just for counting frequency. You know, that is not very important at our stage, but yeah, this option is available under different graphs. So here you go under graphs, you will get all the different bar chart, histogram, pie chart, time series, all different kind. Make sure what is applicable. Before doing any analysis, you need to understand what is really required and what you can do with that variable.
Okay, thank you.
You're welcome. Let me. Yeah, any other question, please feel free to ask. Therefore, I scheduled this on Thursday because first few days you can read, watch, and whatever difficulty, whatever problems you have, you can ask me.
So I haven't done anything about the fill in the blank.
Okay, Six Sigma.
So it is, yeah. So it's only about Titanic case, right? Nothing else.
Yeah, so this, I think few questions are related to Titanic, but other questions are related to some other data which is there, you know. So this is the real data. If you have question 5 or 6 questions related to this, but you know, other, let me pull because I don't remember exactly. So, you know, MCQ in this module, can you see my Canvas part? MCQ is like, you know, you do understand, sorry, you solve the problem, you answer and then you can say this is correct or not correct. So basically you get observe your mistake and you can learn from there. Fill in the blank is another one. So let me open this. So we have, you know, this is based on this data. So, you know, basically this is the data. And based on that, you have to do all these questions, which is, you know, like nothing. A standard, you know, range. So then we come to where we come to somewhere here, Titanic data. Right from question number 24, we have 5, 6, 7 question. I don't know, 8, 10, or whatever question we have. This is based on the real Minitab because we are starting from here. Now Kamini is asking about Six Sigma. So you got the answer of your question? Now,
yeah, thank you. Yeah.
Let me go on Six Sigma. So very simple. Okay. So before going into Six Sigma, let me explain about the Sigma. What is Sigma? I think, you know, you are already knowing about Sigma. What is Sigma? Sigma is nothing but a standard deviation, as you know. So you know the concept of standard deviation. Six Sigma, you know, is the philosophy. As you know, it is and started by Motorola. You know, the company Motorola. And it says 3.14 defect per million. How many defects? 3.14, if I remember correct, million. As 3.14 defects, sorry, per million. Means if you manufacture anything, or if you, let's say you are manufacturing iPhone, or you are assembling iPhone or something, you are assembling 1 million iPhone, then only 3 to 4 defected iPhones can be tolerated. So this is a philosophy which was developed by Motorola, and after that GE and all big companies, they use the this Six Sigma philosophy. Another thing, let's look into the FedEx and UPS. How many parcels do they ship every day? I think if I roughly say 1 million parcels are shipped by FedEx or UPS, how many parcels can be misplaced or can be lost or can be delayed? About 3-4. So this is the basic philosophy. Now let me go and explain about the sigma concept. What is sigma? Kamini, you know about the sigma or standard deviation, because sigma is the standard deviation. 6 means 6 sigma means within 6 sigma range. So let me plot a normal distribution. Or first is, okay, what is sigma? Sigma is nothing but a deviation from the mean. So let's look into, I take the example of 5 students in my class, or I'm teaching for kindergarten. One is, let's say, 5 years old, one is 6 years old, one is 8 years old, one is 7 years old, and one is, let's say, 5, 6, 7, 8, and 4 years old. I have these 5 students. What is the mean of these? 5 plus 6, 11, plus 8, 19, 19 plus 11, 30. So 30 divided by 5. So we have a mean of this. Average age in my kindergarten class is 6 years. Now what I need to do, I need to subtract from this. So -6, -6. Hope you are following my whiteboard. -6, -6, -6. Okay. Now, what is the value? -1. 0, 2, 1, and -2. And if I do, I sum all of them, then I get what? 0. Then there is no point of summing all. Then there are 2 ways to get some meaningful insight about this. One is to do absolute 0 or absolute, absolute value of each value and sum them. Or second is to do square. So one thing I'm just doing, and then that is used for mean absolute deviation, and square is used for standard deviation. So mean absolute deviation, I'm just making absolute value. So I'm just 1 minus 1 is 1, 0 remains 0, 2 is 2, means whatever sign, and this remains 2. So what is the absolute value here? If I sum, so absolute value, sum of absolute value is 6, or, so basically this is known as absolute value. So I just write 6. So this we are not using as of now. Now let's do the square values. -1 into -1, which is 1. 0 is 0. So I'm just doing a square. 2 and 2, 4. Again, 1, -2 and -2 as 4. Now we get 10 when we do the sum. So what is the standard deviation? Or first, we do the variance. Variance equal to here we go. Variance equal to 10 divided by n. What is n? How many values we have? 5. So basically n equal to 5. So what is the variance? So 10 by, so basically variance equal to 2. Now we need to do a square root. So basically we did here the square, we did a square. Now we need to do under root or square root. So what is the value? So sigma equal to square root of variance, square root of variance. Are you getting me? So this is the relationship between standard deviation and variance. So whatever value we got here, we got 2 and then square root of 2 is standard deviation. Is it making sense? Is it making sense? Now I will come on the application part.
Can you go over again for the middle part where you get there?
Oh, this is used in mean absolute deviation. So we are not just following, but I just gave this concept. So just ignore this as of now. Please ignore. Okay, don't follow now. Okay, let me pull then slides so you can better understand what I'm trying to say. Module, and let me go on the slide part. So can you see my slides?
No.
Oh, you can't see. Oh, because I'm just showing my whiteboard. So just a minute. Screen 2. Can you see my slides part?
Yeah.
Okay. Okay, can you see? So variance is
pizza.
So here you can see this is a variance. Sigma equal to square root of variance. Now I have to explain one more concept here. And now this is called mean absolute deviation, where we use this. So 6 upon 5 is mean absolute deviation. So this is the concept for which we use. Is it making sense? So mean absolute deviation, what we got there? We got 6 divided by 5, and that is 1.2. 1.2 is mean absolute deviation, where standard deviation is square root of 2. Now here you can simply understand one thing. If you look into this, you can understand, please remember the notations. If you remember the notation, sigma is used for population, small s is used for sample. So this is population standard deviation, this is sample standard deviation. Now, population standard deviation is divided by population size or capital N, where standard deviation of sample is divided by sample minus 1. Therefore, sample standard deviation is always little bit bigger as compared to this, because numerator is small, n minus 1 is small, so the whole value will be bigger as compared to the population. So always remember, if you get 2 standard deviation, few calculators, they give the 2 standard deviation. Please make sure the bigger value is for sample, smaller value is for population. Is it making sense to everyone? Okay. Now we go to whiteboard. Just a minute. Okay, so here, we were doing this absolute mean absolute deviation is 6 divided by 5, which is 1.2. Mean absolute deviation, MAD. And this standard deviation is square root of 2. So you understand how to calculate. Now look into that. If my entire, all students age is 6 years, then what is the standard deviation of the class? Let's say all students 0. So Muhammad, what is the learning? What is the lesson that you see? What conclusion you can draw that if everyone is of same age, then no deviation in the age.
Exactly. So no deviation if everything the same age.
Exactly. And what is the important thing in the world? Nothing can be ideal or exactly same age. So basically 0. So what is our, inference from this learning? What should be the ideal value of sigma?
Practically near to 0, not 0.
Yeah, very, 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 very close to 0, or approximately
Yeah.
0. I mean, this is what we look in everything that we do in our life. I mean, if we need a consistency, if we have a data that is very random, or you can say, in a class, let's say I'm teaching this class, one person is about 20 years of age, one person is 60, 76 years of age. It's a very, the deviation is very high. Similarly, if you look into the customer profile, customer buying behavior or customer spending behavior, or whatever they are spending, or think about all the kind of data that you have. If variation is very high, that means the deviation is very high. That means there is a wide range in consistency, and then you have to look. So ideal situation, practically or ideally, we can't have 0 value in real life. But if we can have sigma value as close as 0, that would be ideal. Now look into, because few industries, they are using 6 sigma. For example, like, okay, so let's I give this example to my students related to runway of any airport. So let's say this is a runway. This is the front landing gear, follow this middle path, or just this middle line. This is the outside, or this is outer line of runway. 90, almost how many flights land and take off every day? I think hundreds of thousands, if I'm not wrong. The front landing gear has to be right here. Okay. So this is first condition. This is a, average, or you can say the mean. Now, A condition is like, the front landing gear is landing here. B condition is, let's say here, the landing gear is right here. The third C condition is here, like. So the deviation from the middle is, okay, this is smaller. This is bigger as compared to A, and this is biggest as compared to all three. Which is having highest risk? Which flight landing is having the highest risk? The C, because it has higher deviation. Oh, sorry, it is the center line. This is the higher deviation from the center. This has the lowest, or this has almost zero, almost zero risk, or very minimum close to zero risk. Are you getting me? What I'm trying to say? So higher the deviation means higher the risk in whatever you do. Close to zero, better is the. So this is the one of the application. Now let me go on to data part. So third part of standard deviation is higher deviation is bad means you have higher variance. Let's say you basically you can't make precise decision about that. Let's say you are a owner of any grocery store, okay, and you have a membership or data or membership of the customer. Let's say at the end of the month, let's say you have hundreds of customer, and one customer is spending, let's say, only $2 in your grocery store, and one is spending 20,000. And in between you have whole range. Somebody is spending $100, somebody is spending 20,000, 10,000. What conclusion can you make? If you say, basically, or otherwise, let's say in an organization, a very simple question, let's somebody is earning 50,000. Most of the people are earning, let's say, 50 to 60,000, and one person is earning $2 million. So basically, we have to have, if you really want to make a good decision, the deviation or variance in the data must be, okay. It should not be very wide as compared to data. Is it making sense? Yeah, I mean, if you really want to draw some conclusion based on data, then data has to be precise. Now, what I was trying to say, okay. Now, if you plot a data, let's say, do you know this is called Gaussian curve, bell curve, or normal distribution? And this is called mean, or you can say average. So mean plus sigma. So this is 1 sigma, this is 2 sigma, and this is 3 sigma. Similarly here, this is minus 1 sigma, minus 1 sigma, minus 2 sigma, and here minus 3 sigma. So mean, so what is the range? Minus 3 sigma to plus 3 sigma. Empirical, if you remember, if you studied the empirical rule. So what is the empirical rule says? Within 6 sigma, how much data should be there? 99.73%. How much? Within 6 sigma range, 99.73% data must be there. Is it making sense? Means from here to here, this should be 99.73. Is it making sense? Okay, let me show you here. So I'm going on Minitab. So if you remember, and very important thing, this is a normal distribution, but standard normal distribution, the mean is always 0 and sigma is always 1. And I can show you that sigma is always 1, and this is, if you normalize standard sorry, I forgot the term. So standard normal distribution, mean is always 0 and sigma is always 1. So let me show you on Minitab. So can you see my Minitab? Now I go under this graph. Under graph, I have probability distribution. A view probability. Okay, I go here. And here I have normal distribution. Here I can put a mean and for normal. And then I can put the X value, and which is 2 of the X value, which I can say, or I can put here X value is -3 and this value is 3. And here we go. So can you see within -3 sigma and +3 sigma, 99.73% of data will come. Is it making sense to everyone? So who asks? Kamini, do you get the answer of your question, 6 sigma? Kamini, do you get the answer? So yeah, this is 6 sigma. Similarly, you can do 5 sigma, 4 sigma, 3 sigma. If you remember, I can show you again, what is the value of 5 sigma or 4 sigma that you studied in so 95. So here you can say 95.45% is 4 sigma. 2 sigma that you studied 68%. So I can show you right here. 2 sigma is so -1 this side, +1 this side. So you can see 68.27%. Now, how you can normalize and what is the way of getting, sigma, how you can do that? How you can prove that, within 6 sigma, you can get 99.73% of data. So very simple. If you have this data, let's say this is the age. This is a very small data. If you have really thousands of numbers, you can do and you will get precisely the same value. Let's say this age. How I can go? I go under graph and I can plot a histogram. Where is histogram? Okay, right here. I can do this age and I can do this. So when I plot this, I get mean value and I can standard deviation value. So how we can get the this value? Let me explain. So mean. So what is our concept? Mean plus 3 deviation, mean minus 3 deviation, within that range, 99.73%. So mean, this is, I'm just roughly, 30.92. I'm just roughly doing it plus 3 sigma. So 3 into what is the sigma value here? I'm roughly saying 12. So what is the value we are getting? 31 plus 36. So how much? 31 plus 36, which is 67. So this is the upper value. Lower value, 31 minus 36. So which is -5, which is not the age here. So -5, or you can roughly say minus or 0 to 67. You can get 99.73% of data. So now, just do this exercise. Just a minute. Okay. So let me, so here I'm just sorting this data. So I do this data sort. And I say the age, select, and I can say increasing order. Okay, go ahead. So here we go, and I got this. So you can see this is sorted from this, and you can see all I have to see up to 67, sorted data up to age 67. You are able to see my mini tab. If you are able to see, keep. Where am I? So, okay, we have, okay, this 67, which is how many? 2,444. How many data points? Out of how many? 2,478. So what is the percentage of out of this? So 244. Few data points are missing, so I can't say, but 2,450 and 2,000. So let me give the calculation. So 2,448 divided by 2,450, because we have only, what percentage we are getting here? Can you see that? 99.91%. Can you see, Kamini, this?
No.
No, you can't see my, okay,
No.
the calculator. So just a minute. I have to share again full screen. Okay, screen 2. Can you see this now? So you can see here. Oh, sorry. See, I just did. So you can see 2,444 people are up to age 67. So 2,444 divided by how many total? 2,450, 2,450. And you can see 99.73. So basically 99.75, which is coming. So this much data is coming within 6 sigma range. This is empirical rule that you have studied in chapter 4, I believe. Is it making sense?
Yes.
So any data that you have, mean plus 3 sigma, mean minus 3 sigma, within that range, you will get almost 99.73. Similarly, you can do for 4 sigma and other sigmas. So basically, this is the concept that I wanted to explain. Any other question, please feel free to ask. No question. If you don't have question, I would like to say, have a wonderful night and enjoy the evening and keep asking the questions if you have. And your first module grades will be given tomorrow, because today is the last day of discussion. As you know that I put Monday is the due date, but after that, if somebody wants to do with late penalty, so you can see module 1, the fill in the blanks. Let's say I'm just going to show you. The May 25th is the last day of all the assignment in case somebody missed or something. So you will see the grade of discussion by tomorrow. If no question, then I will say have a wonderful evening and wonderful weekend, and see you next Thursday.
Thank you. Bye-bye.
Most welcome.
Thank you so much.
Most welcome.
Thank you.
Most welcome.